Login accepted.
So, hello and welcome. My name is Filipiak. I have been working in Colibra for 4 years as an AI engineer, but my career actually started as a software developer. During today's talk, I would like to take you with me on the journey, which should end up with not only a great quality AI model, but especially with a scalable and observable application, which ends in production after just one merge. Probably a lot of the things which I will mention during this presentation won't be of surprise to you, because actually what we will be talking about today is a software development process. But I would like to show you how the mind of an AI is important during this process, but also how software development and proper engineering skills are very crucial for developing and putting into the production our AI features. So, I think I might have already disillusioned you a little bit with the description of this presentation about how working with the AI actually works, but why not to stop there? Let's talk about working with the AI. Have you ever heard about ELIZA? This was the first software which sort of passed the Turing test. So it passed as a human being. But what did it have at its core? The engine of ELIZA had just a huge database. It looked into some keywords in the phrases which were passed to it, and based on them, tried to respond in the best possible way. So actually, it was sort of like a bunch of ifs. A bit of a disappointment, isn't it? But to actually get to this sort of result, first of all, we need a lot of data. And here comes another issue. I don't know if you know how much data we are producing every day. It is estimated, according to different sources, let's set on 2.5 quintillion bytes every day. This is 10 to power of 9 gigabytes every day. So we need our data, we need to build something. But whenever we get to some task, it turns out that either this exact data, which we need, does not really exist. The data is dirty, it's not usable, it requires a lot of work to make it usable. Maybe it is not accessible to us, or it is not labeled, and we need to put a lot of effort to take some advantages of it. So this is how everyday data scientists work is. Data issues everywhere. We are expecting to work with the fantastic models, building amazing neural networks, doing a lot of machine learning, deep learning, and all of that, buzzwords which we all love. But in the end, it's all about the data and the issues which come with it. So our expectations are definitely not met with the reality. So let's talk about engineering side of it. When the engineer comes and they want to work with the AI, yeah, we will build this awesome model. It's gonna be cool. But this is a bit of the issue, that everyone are so focused on this amazing model which they will build, that they are forgetting that it's not only about the model. There is so many things surrounding the process, surrounding the model itself, that needs to be done, and everyone are so hyped about this one only thing that when they meet the reality of building all of the pipelines around it, all of the code around it, making the way to the production, it gets quite disappointing, because there is so much engineering surrounding the AI that for some reason nobody really thinks about. So, as I do not want to leave you too disappointed after this presentation, I would like to set some proper expectations for it. So, this is the use case about which we will be talking about. This presentation is about the development process. The development process surrounding building the working AI services, this actually applications which at the core have some sort of the AI features. What we are doing at the Colibra in the AI engineering team, we are creating services which are available and used by our core platform, and are just boosting and supporting some of the features of the Colibra. So we are not an AI-first company. We are not developing AI features to be used by our customers. They are only supporting the things which our main product, Colibra, is doing. Because we are working on the service basis, we are doing AI as a service, it is very crucial for us to be as fast as possible. So our response needs to be almost real time. And because we are creating services, and in many cases, they need to be single tenant and deployed per customer, so, you know, a lot of services, we have 500 customers, it is a lot of resources. So we would love to keep everything small as possible, as fast as possible. So with that comes being small, models which are fitting in memory and not that complex, especially that we are working with our customer data, coming from their Colibra instances. And you would be surprised, this is not that much to work with, so it also ends up with not that big of the models. We are also working with a very small, very agile team. We have 3 different positions: data scientist, AI engineer, and MLOps. But the responsibilities in between us are very, very fluid. So sometimes we are sharing a lot of tasks, and it is very easy to communicate in between us. Sometimes in big companies, those responsibilities are very rigid, and it is very difficult and strict on what part of the team does what. How we are doing things with our services. So Colibra has their in-house built AI deployment platform. It is based on Kubernetes. We are working with Docker. We are deploying on the microservice basis. In general, our applications are coming in multiple small parts, which are communicating with each other through some messaging layer. Our platform supports a lot of nice features, like scaling, automatic scaling, but also cost optimization. With our microservice architecture, whenever, if any, of the sub-services within a single application is not as performant as any other, then we are able to scale up only this one component and do not scale up the whole system. I mean, you know, cost optimizations, 500 customers, 500 possible instances. We want to cut the cost whenever it is possible. With this sort of approach, and with having everything in Docker, communicating only through the messaging layer, it is also possible to use as many different technologies as we want. For example, we have our microservices both in Java and Python, and with a proper data contract, we are able to communicate easily with them. It also allows us to do an easy plug-in, plug-out of the services whenever they need it, if we need to swap them. Another feature which was created within our platform is ability to do the retraining of the models and right after the retraining, doing a smooth transition to the new models. So we are redeploying our newly retrained models so that it wouldn't be visible to our customers. So, okay. So this is how we work, this is how our services work, and we will now talk about how to get there. So, let's build something. How does it start? Our data scientist is coming to the team, and they are telling us that, hey, I talked with the PM, and we have this great idea how to support some of the Calibra features. So, yeah, it sounds feasible to do. It is a nice feature. PMs would love it. Customers would love it. We should do it. So where do we start? We start with asking questions, very difficult questions. So as we have already stated, we need data. So the first question is, do we have data? But not any data. Do we have enough data? Is it the right data? Because even if there is some, it doesn't mean it is enough to build our feature. When we are starting to build it, we need to think if this model which we will generate, which we create, fits all. When we are talking natural language processing models, some things might not work the same for all of the customers. When we are talking about analyzing comments, the natural language as it is in the internet probably will suffice. But if we are talking about legal documents, basic natural language processing model probably won't be enough, and probably we should adjust it. Maybe at some point we'll notice that we need to adjust by the customer. So, yeah. It means we need to know. But after that, there are coming a bit of more obnoxious questions. Because we are working on the microservice architecture, and we want our features to be as small as possible, we need to start asking questions like, how fast can we be? How fast do we have to be? Because if the response takes a couple of minutes and it's about getting the recommendation which should be visible in the search box, then probably this is not what we want. So if we are talking about the retraining, how fast do we have to be? How often do we need to update our models? So do we need to update the models? Are they maybe static? If we are updating, so how often do we update? How long does the training happen? Because if the training is happening nightly, but actually it takes like 2 days to retrain and we need to redeploy every day, then probably we are 1 day short and we are not able to do that like it. We need to make sure that we know of our limits. If you are deploying on a small cluster and we do not have much resources, what are our limits? How big can our model be? Well, because there might be some maximum size to it. So how much resources we have, how much CPU, how big of the cluster there is, how much node. Maybe we need to deploy it locally for the customer. It might happen at some point. There are so many questions which, as you can see, are quite quickly moving from the data science sphere to actual engineering side, because we are asking about non-functional questions, how much resources we have, how good we need to be. So how fast? There's a lot of things which need to be taken into account. And why is that? We'll get to it in a moment. So when we are thinking about the model, so like already showed you, people are thinking the model. So yeah, we are building a model. So what is the most important thing about the model and the AI? Of course, it is its quality. So when people are thinking usually about working with the AI, it's like, yeah, so I'm building the model, it needs to be good. So we need a good metrics. But this is just a little bit, this is just a drop in the ocean. Because if we need to be fast, if we have limits of the resources, we need to make sure that our processing also will fit into our model, into our business model. So we need to measure a lot of more things. We need to measure time of the response overall. We need to measure every part of the processing, not only the model itself, but also the pre-processing and post-processing. We need to make sure that our model actually will fit into the memory and make sure that after the retraining, it also will still fit into the memory. So it's only a little bit what we are usually thinking, but all of that needs to be taken into account. But is that all? Here I would like to introduce you to something what I will call a feature. Because sometimes it happens that when we are talking about building a model, it means that we are not building just one. Sometimes our whole model, our whole feature, actually consists of multiples of them. So with that, we need the model report for every step, every model which fits in it. We need to know the time of the full processing from the step one to the other. Why do we need to know that? Well, optimization, for example. If we need to be faster and we know we are not fast enough, we need to know which part of the system actually slows us the most. So we will be able to focus on it in the first place. In here also I included something what I like to call technology research. Sometimes it might be that we want to use some out-of-the-box solutions. So we need to find out what will fit our model, our idea, what will fit, what will be the fastest, maybe what will work the best with our type of data. And to also show you the difference in between the model and feature, which I have distinguished in here, here is an example. So sometimes we have multiple steps within the processing. When we are talking the model, usually people are thinking neural network. It has to be neural network. Well, it doesn't have to be, but for the purpose of this example, let's make it. In this place, we have encoder, which is sort of a neural network, which transforms the input data into some sort of the vectorized representation of that data. We can do a lot of things with this sort of data later, with this sort of vector. What we are quite often doing is, with having some sort of the reference data, we are able to find the most similar data to the one which actually came to our system. So for this purpose, we are using a very simple k-nearest neighbors, or right now very fashionable approximate nearest neighbors, especially for the big data sets. Algorithms. We are using this sort of engines. And it means when we are creating a full report about how good we are doing, we need to take into account each step. We need to take into account encoder itself, how long does it take to encode the data, how long does it take to pre-process it, and then separately we need to know how long actual search within the ANN engine is happening. Because those two steps are totally separate and might need a separate optimization. If the encoder is very fast and KNN search is very slow, we know this is the part where we need to focus. It might be the times are very, very similar, but it might be that that one part is 10 times, 100 times slower, then optimizing the other one probably is not the crucial part here. So, our data scientist came to us and created the POC. They started to work a little bit with the AI engineer on that. They have created the input, output, everything is going through. So we are creating our report. And the first question is, of course, are our requirements met? We have asked a lot of them at the beginning, right? So usually, they are not. It is too slow, it is too big, it's not gonna work. And if our requirements are not met, it means that we are not able to put it into production. So where is the value in that? So we are doing our iterations. We are doing optimization work. We are trying out to do faster. We are trying to be smaller. We are creating our reports. And again, it might not be it. And it might take quite some time. It might take quite some iterations. So this is why asking the proper question in the very beginning of the development is crucial, because it will shorten the time and the number of iterations a lot, because we already have some expectations about it. So bringing the engineering side into already the data science part might be very important. Although, of course, there come some disadvantages to that, because sometimes we need to face some trade-offs. Of course, when we are talking AI, we want to be as good as possible. And our accuracy, our F1 metrics, or whichever metric we are using, we want it to be the best possible. But sometimes we need to decide, do we want to do it great, but actually not do it because we are not able to deploy it, or we will be a little bit worse, but actually bring the value to the product. So sometimes we need to face this sort of reality. So at some point, we will end up with the POC, which actually meets our requirements. And with that, we are almost ready to put it to production. We are creating our service. It probably needs a bit or more cleaning. It needs adding the communication layer. And we are almost ready to go, to put it into our system. So this now seems like a good place, a good moment to introduce you to our data classification system. The following examples will be based on how we created this one. Data classification, as the name suggests, is a classification system which classifies data, but not any data. It is not a very typical use case. We are classifying columns from our customers' tables. So we are classifying, we are giving some labels, suggesting what might be within a given column. It can be name, it can be surname, and this is very important, especially in the cases of the GDPR, when we need to identify the data which might have some personal connection, and might be important to know that there is some data which need additional protection. So in here, you can see a simplified architecture of the system. So as you have noticed, it's not that simple, and it's already simplified. Our classification system was actually patented. So here you can see the number of that. If you are interested, you can check this. So what I wanted to show you, we have just created a service in the previous step. This service could be one of those boxes, especially the one in the box of the called classification models. So our classification system consists of a couple of classification models which are working independently. They are getting the same data, but they are based on a bit of the different approach to classifying the data. So we are getting an overview from different perspectives. After we get these results from the subclassifiers, we are passing the data to the aggregator component, which is also an ML module, which was trained on the outputs of the subclassifiers and returns the most probable value based on the subclassifiers' outputs. What I would like to also put your focus onto is the controller. Controller actually is not the AI piece. Controller is the piece which is an orchestrator of the whole processing. This is what we are calling our main module. Also, controller version is something which keeps the version of the whole system. So, this is simplified. And it's not simple. And I think that this is even more to be proud of, that we were able to be full CI/CD with it. And how do we get there? How did we get there? And how you can get to the full CI/CD of your AI models? Well, so what is the most important? Probably not the surprise to you, but it's testing. You need to test. Testing is the key. And not any testing. It's testing everything, absolutely everything what you can think of. If you are building your model, you already need to think how to test it. Is it testable? And if not, probably it should be done a bit differently. If you are doing one merge, and after that it ends in production, you really need to be sure that everything is tested. And because it is just one click and you do not see anything in between, you need to test everything in a fully automated way. So all of the tests you can think of, you are doing them. This is, for example, the pipeline of our single classifier. So it won't be of surprise to you that there are a lot of very basic steps which you probably are doing in your own processes. We are doing unit testing, we are doing integration testing, but there are also a couple of things which are a bit different and need some AI focus. So, first of all, it's quality testing. We are building our AI for the reason to be as good as possible, right? So if we are doing some changes in our code, if we are doing some changes in our preprocessing, which is also built into the module, if we are doing anything, then in each feature branch, we are checking that we haven't messed up anything, that our model still returns as good results as it should be in the very beginning. So for that, we need to, of course, have a proper data. And this is something what usually comes from our data scientists or from the earlier stages of the training of the original model. The other point which I would like to show you is performance testing. This might not really sound to you like something which needs some AI insight. You are probably doing it a lot. You are testing how much of the strain your component can actually handle, how fast you can be when when you are swamped with the messages which might come towards your way. So, but with the AI, of course, it is about data, the amount of data, but it's not only that. Sometimes we need to make sure that there are some edge cases which might actually slow down our model. As an example, we can talk about the NLP models, which are not very good with out-of-vocabulary words. So if we have our basic model, it will work quite nicely. But if we are putting there some unexpected words, it might slow down. It might cause a bottleneck. So it would be also very important to include this sort of data to measure our performance. We need to make sure that the quality of data is also good. As an example, when we started creating our data set for one of the models, we created a lot of samples, but they were duplicated. And the model actually was only using the distinct values. So even if there was 100, 1,000, or even 10,000 samples, it all treated them as one and the same. So actually, internal knowledge of the model is very important to properly specify the performance test set and make them actually do their job. So we have merged something new into our subcomponent. Our pipeline passed. So what happens now? So we are using the tool which is called OnTrack. We are using the promotion levels that are assigned to each of the branch, to each of the version of the component, that so that we know at what state they are. So whenever the branch, the component, the full version is assigned with a proper promotion level, we are triggering some events. So in this example, after the classification subcomponent gets merged, and we are assigning the proper promotion, we are triggering an automatic merge to our main component, which is a controller, which keeps the track of the all versions of the subcomponents within the whole system. So after that, what might happen? We are triggering another pipeline. About OnTrack, it also serves to us as an overview of everything what we have done. All of the pipelines, all of the metrics which were created during the running of the pipelines are also stored in there. So this is also our historical overview, out of which, you know what, you can create dashboards, which we also have. So we have historical metrics of all of our branches so that we make sure that everything stays as is. So as a reminder, here is our system. We have our subcomponents, we have our main component. So we have merged, we got a promotion. So we are triggering another pipeline. No surprise there. So as this is a separate component, we are also going through the particular steps as usual. Unit testing, integration testing. But at this time, as this is our main module, which serves as a version of the whole system, we need to make sure that our whole system is working correctly. So within this particular pipeline, what we are doing a Docker compose, and we are running the system in a bit of the artificial way, but just making sure it runs and nothing broken. For example, maybe somebody make a bug in a messaging layer in the component, and it's not passing proper messages. So we will notice already in here. Also, our validation, our quality, is the key part. We are never forgetting about it. On every step, we need to make sure our system still works as expected, because this is what we want out of the system. We want it to work great, to give us the best metrics possible. And when all of our tests are passing, what we are doing, we are deploying our system on our test clusters. We have our platform, we have our production clusters, but of course we have our testing environments also. So this is where we end. And after that, no surprise there, another pipeline. We are triggering another set of tests. We have our clusters currently both on GCP and AWS. So we are deploying our system on our test environments for both, for AWS, for the GCP. We are running, no surprise there, again, the quality tests, because we want to make sure that maybe some environment issue might not come in and something got messed up. Well, a lot of things are unexpected. So we have those, and we are doing, again, our real-life performance tests. This is as close as we will get to the production at this point. Our test clusters are as similar, as close to the productions as they can be. So we are hammering our system with the performance, with a lot of data. But this is not enough. Our system supports scaling. We have microservices, and we want to make sure that if some unexpected amount of data is coming to us, our system will be able to scale properly in the real environment. So this is why we are doing it almost live on the test. And actually, yeah, probably we never have seen it in real life happening, but our tests are passing, so we are quite happy with it. And if everything goes well, we are deploying into the production. So all of the steps went through. So we are there. We have done one merge in one repository, and everything ended up in the production. So what happens now? So journey doesn't end there, as you probably know. So we need to make sure that everything runs smoothly, that there are no issues. And how do we make sure that everything works smoothly? We need a proper observability of the system. So we can distinguish like two parts of that, usually. So we have the entry point to the system, which sees what actually to the system is coming in. But also, we have the whole AI system, which has some specific quirks to it. So how we are making sure everything works? Of course, by asking appropriate questions and making sure we are able to answer them. So whenever something comes in, we want to know, for example, if we are using REST, what endpoints were hit? Did they fail? How often they failed? Why they failed? Was it too much of the data? Was it just one particular customer? What customer actually is requesting our data? So there are so many questions which we want to know, and they usually need a proper answer to it. So somebody needs to make sure that we are able to answer them. So it might be either the part of our system, or it might be the part, for example, of the environment when we are putting things. Those questions, fortunately, are usually answered by our platform. But there are also a lot of questions which they cannot answer. Because, if something goes wrong, we want to make sure that we know where it goes. So, yeah, no surprise there. We need to have a proper logging. We need to know where our system is vulnerable. We need to know where something might go wrong. There are some particular quirks to some models that maybe your data scientist will know that you need to make sure that you are not giving there some data which might break it. And we actually have thought about a lot of the places where it can break, but if we haven't thought about something else, maybe you want to make sure that in this place or another one, you are properly monitoring things. But this is the level of the logging. But what was also the crucial part of our system? It was that we had some limits, and we knew them from the beginning. So what are we doing? We need to also know if those limits are not exceeded. Because maybe unexpectedly, after some retraining, there was so much data that we actually start to be very, very close to the limits which we have set in the very beginning. So probably we need to make sure that we are able to do that. If we know we need to be very fast, we need to make sure we are able to measure the time of the request to come in and to come out. proper logging, proper monitoring, however you call it. Whenever you are building the service, you need to take it into account. You do not want to put all of those logs after you have created your service. So first thing first, logging, appropriate places. Sometimes they require some insight from our data scientist. So our application code needs a logging, no surprise here. We need proper monitoring. So we are doing our online monitoring, for example, of our cluster, of our pods, of our limits, of our resources, how we are using them, are they getting close, maybe, to what is the limit in general set for it. So, and out of it, if we have a proper monitoring, we are exporting it, we are creating our proper dashboards, our historical data, we can view it. We make sure that if anything went wrong in the past is happening, we know it. And to know it, it's very good to have alerts, because if something goes wrong, you want to know it fast as possible. Yeah. I mean, but we all know that, right? And now the cherry on top of our AI system. So automated retraining. So we have talked a lot about how to get to the production, how to have a proper observability in there. But when we are doing our retraining, what is happening? We are using our customers' data. We do not see our customers' data. The retraining is fully automated. And after the retraining, we are automatically deploying it into the production so that the new version is available to our customer. So how we are also applying this observability here? Well, proper logging and proper dashboards and proper monitoring of it. This is, for example, a very simple and very high-level overview of our retraining dashboard. It only has the date, our customer, when it happened, and if the given step was successful or not. Of course, the key part in here is the validation step. Because if we are automatically retraining, we need to make sure that after the redeployment based on the customer provided data, it is still as good as possible. So validation step is crucial here. And we cannot really forget about it. But this is only like high-level overview. We have very detailed dashboards about our retraining process. We are gathering a lot of data every night on every customer on whose data we are doing our retraining process. So the most crucial part is, of course, the quality metrics. But we need to make sure that everything goes okay. Maybe it turns out that after some retraining, the customer is not happy with it. So for that, we are able to pick inside of our dashboards, of our historical data of the retraining, and we can make sure how well we think we did, and but also how much of the data there was. So for that, we have our data summary. We cannot see the data on which we are retraining. And for that, we need to go a little around it. So we are gathering some stats. We are creating some summary of the data. For example, how much of it there was. So if the customer wanted to add one column of a given type, we see how much of that data they actually provided to us. We can see on our quality metrics dashboard how well we think we actually worked on it, or if actually we were able to train on it. Because sometimes the data provided might not be enough. And this is where the full overview of the data of the retraining process is needed. And of course, we are deploying on our own cluster, as we really need to make sure, our cost optimizations and all of that. We make sure how big of the job the retraining actually is. So constant monitoring of our pods, of our resources, always comes in handy. And of course, the time of the retraining. For that, we also can easily see how much, for example, data we have and how it translates to the retraining process. And sometimes the data is not consistent, because maybe it turns out that the customer has a very specific type of data, and for some reason, it prolongs our process. Maybe it needs some additional inspection. So, we have went through all of the steps. We have started with an idea. We wanted to create something fun, and we created it. But getting there and making it available to our customers, making it available to be used, it took quite a long time. It took quite a lot of effort. It took quite a lot of engineering and software development effort. There was a bit of the AI in there. AI was also very crucial to some parts of it. So we needed to know about some specifics of it. It was always there, but only like a little bit of the presence of it. So how I like to define AI engineering. I like to look at it as like this scale here. So on one end, we have data science. So data science is usually this what we are calling all that fun. So building the models, working with the data, but we already know that working the data is usually most of the time we are doing, not creating the models. And on the other side of the scale is software engineering. So something which usually doesn't have much to do with doing AI. But when we are talking the full process of creating this type of services, we notice that a lot of questions which we need to ask and a lot of focus in the very early stages, even when the data scientist is working, has a lot to do with the software engineering. So AI engineer is somewhere in between one end of the spec to the other. Sometimes it is closer to the software engineer, sometimes it is closer to the data science, but there is no rigid line in there. Whenever we are creating our software, we need to be mindful of each side of the scale. We need to make sure that we are asking right questions at the very beginning, the engineering questions, and throughout the whole way to the end of production, to putting everything into the production, we need to be mindful all the time that there is AI in there. And how are we able to make sure that everything works well at every stage? And we need to know a little bit about the models at every stage so that we can ensure that our process goes smoothly and we do not forget about the core feature which we have, which is the quality of the model. And this is what I wanted to share today with you. So thank you very much, and see you later, probably.